Antenna basics. Any of the field patterns or power patterns can be represented in the 3D spherical coordinates. Generally, radiation pattern is a 3D plot. So, not only by the 3D plot, we can represent it by plane cuts also. Plane is two-dimensional. So 3D plot can be understood by taking the plane cuts. These plane cuts should be through the main lobe. We have various lobes in the radiation pattern. When you want to take the 2D plots, 2D plane cuts, those plane cuts have to be taken through the main lobe only or major lobe. Two such cuts at right angles we have to take. So those two cuts are principal plane patterns. Two such cuts are plane cuts at right angles are called principal planes. Principal planes. Okay, two such cuts are called principal plane cuts. Okay, and those patterns are principal plane patterns. And the patterns obtained from these cuts obtained from these cuts are principal plane patterns. Already we know pattern can be taken for the field or for the power. And generally these are XZ and YZ planes. Generally XZ and YZ planes. In some cases, single field component is also enough. When it is possible here, two things I have told, XZ and YZ. But in some situations, single is also enough. When it is possible in the sense, it should be similar in both ways. If you take XZ cut, whatever the pattern you are getting, same pattern if you get by YZ cut also, then we can tell only one cut is enough. So for what type of patterns, these two cuts will be same for the symmetrical pattern. Okay, so single field component is sufficient. Single field component is sufficient when pattern is symmetrical. It is very good point, we can tell. The pattern is symmetrical with respect to z. According to these planes, xz and yz planes, the pattern is to be symmetrical with respect to z axis. Then even you take xz, yz, both will be same. Okay. So in this case, just one cut is enough. For example, simple diagram I will take. This is z axis. If you take, then the main lobe of the radiation pattern is like this. These are side lobes, back lobe I have taken. So this is symmetrical. With respect to z axis. So xz and yz they have told. So if you cut along xz or if you cut along yz, both patterns will be same because symmetrical with respect to z axis. Then to see the minor lobes, to see minor lobes clearly, take pattern in dBs. That is the advantage of the dB. Okay, because you can check logarithm of 100, logarithm of 1. Without dBs, that means without application of the logarithm, the values of the intensities are 100 and 1. To represent this 100, if I take this lobe, to represent this 1, very negligible thing I have to take. A loop is there. This is 1. So scale is, if you take as per scale, this 1 we cannot able to see because 1 and 100 are having large variation. So, but when you apply logarithm, this 100 will become 10 and this 1 will become 0. You see, the gap between 1 and 100 is very large, that is 99. And the gap between 0 and 10 is just 10 only. So, if you represent the minor lobes can be represented clearly, noticeably we can able to do. If you confuse with 0, you can take here 2, otherwise logarithm of 2. Okay. So some other value will get 0.3 like that we will get. So the gap is reduced, so we can able to clearly observe these minor lobes also. So to provide, to see, to observe the minor lobes, we have to take dBs into the consideration. So when you are dealing with power, 10 logarithm you can apply. When you are dealing with just fields, you can take 20 logarithm. Okay, thank you.